Now I can see if if anyone comments. These parts are really nice quality. I'm just checking to see if there's any ringing or anything like that, and there really isn't. He has a really nice profile. So I'm going ahead and just taking everything apart because I found out that some of the parts were bound up. Or maybe I should, I don't know. And I just said screw it. I'd rather just go ahead and fix it from the get-go than getting a V2.2 working and then doing it over again with V2.4, because V2.4 is just that much easier to tune. The XY joints are just so much easier. Let's see here. I don't know if you guys can see this, but these essentially the y-axis would move, but then these here, just how they're installed and just depending on tolerances and things like that, they're what am I saying? They have a lot of friction. I've loosened this joint up. This one over here, yeah, I can barely, it takes a lot of force to move that. So same thing with this. These bearings actually don't move at all. So yep. Yeah, honestly, it's probably going to take longer for me to take apart this 2.2 than it is for me to. Alright, that might not be accurate. Maybe for everything but the afterburner does, with all the heat sets. I'm not set up right now for heat sets. I'm not going to do heat sets tonight. There's just too much. That's just too much to do in one night. But I'll probably stay up here for another hour just because 11 o'clock is my cutoff time. After that, I go to bed. Otherwise, I stay up until 1 o'clock and don't have any energy for the next day, and that's never a good thing. I'm just so happy to never have to, try to fiddle with like these. I'd always have the little 0.3 millimeter shims, and they were just always a pain to try to space it out just perfectly, and maybe one of my pulleys would be hitting the other one, or maybe if I deflanged it, it wasn't quite right. It's a nightmare. Yeah, I will not be changing the Z drives on this. I think I printed everything but the base black color for the Z idlers. I honestly forget. I don't know. I think you can replace the Z idlers. There may be a slight mismatch, maybe like a fraction of a millimeter over the entire height of the printer. It's probably not a big deal, but I don't know. I'm tempted just to leave these here because they theoretically should be relatively easy to swap out down the road if needed, but we'll see. And also, before I put this back together, I think this Voron's been sitting for a little while, and this axis right here just I don't know if you can hear that, but it's kind of gritty, and it's been sitting around too long. So what I'm gonna do is, probably the dust is kind of maybe gumming up stuff a little bit, but I'll end up washing or cleaning that out with alcohol, and then going ahead and lubricating at least the Y and X rails. Yeah, I can swap the Z idlers. For some reason, I've been having issues with layer adhesion today on my V1.8. I don't know what it is. I'm not sure if maybe my basement is more humid than where I used to live, and maybe my filament's wet. But even just printing these little blocks, this one's looking, I mean, other than whatever that artifact is, I've been getting warping even with parts this small, which is crazy to me. I washed the Alta-Stick with dish soap. I'm not sure if I didn't check the recommendations to see if I should do that, but I've done that in the past with other ones. And then that didn't work. I tried acetone, and that seemed to work a little bit, but I still have a little bit of warping on this one back here that I just put on. What sounds wrong, Raymond? Let's see here. This is just a cute little tool head. It's so tiny. Let's see here. I guess I'll work my way around. We'll go over here now. Yeah. It is pretty gritty, but yeah. Honestly, if I was really motivated, I guess I could try and we'll see what it sounds like. If it's still really bad after cleaning it, which the cleaning should fix it, but if it's still really bad after that, it should be fairly easy to grab one of these Z rails that's maybe a little nicer quality, and then stick that kind of gritty rail back on the Z axis where it doesn't matter as much. But like this one feels great. And this is really cool. I haven't seen this before. It's probably almost impossible to see. But there's this little like metal clip with dimples that snap into the groove on the rail. And I'm not sure if he put them on there or whatever the rail supplier put them on there. But that's really cool. It does, reduce the total travel of the rail slightly. And I'm not sure if that will be an issue here, but it does just look, I always have concerns. That's why I haven't taken apart the X-axis all the way yet, because I didn't want the carriage to fall off, because that would just be a bad time. But these are really nice. So I'm trying to think the last time I worked on a V2.2 or a Gantry. I think it would have been back when V1.7 was going to be essentially the V2.2 Gantry on the V1.6 Z assembly. Yeah, that's probably the last time. It's been a while. I think V2.4 Gantry development started in the December time frame, maybe I don't know. It was right around Christmas break. I spent a ton of time over the holidays just sitting on my couch doing CAD. It was a fun time. I'm glad my wife has patience with me, because a lot of wives would have just been like, "What the hell are you doing?" you're spending more time in Fusion 360 than you are with me. That sounds terrible. The other thing here is that he has used, again, he started the build before V2.1 came out, and so he used some pre-install nuts, T-nuts. He didn't realize that you could do post-install. So this is actually the first time I've used pre-install nuts, and they're actually not bad. You know, as long as you don't need to add or remove any, they're quite effective. So I feel like they have more engagement on the channel than a roll-in, but again, I don't recommend that for really anyone, because as you know, if you build a V0, it is a pain, an absolute pain, in order to deal with pre-install nuts, because anytime you forget something, you have to go back through and disassemble stuff. The order of operations becomes really important, whereas otherwise you just kind of do whatever you do and it works well. So okay, I think now I can just, oh, beautiful, perfect. I can slide that off. Ah, yeah, look at that. And see, yeah, these are the clips that, and also the pre-installed T-nuts. I'll just go ahead and get rid of those and put those out here. But I don't know if you can see that there, but there's these little clips that are snapped on, which are pretty cool. But yeah, that is a nice, that is a much nicer rail. So that's what it's supposed to be like. Maybe with a little more lube on that, then, because I'm not sure if there's any here. Doesn't look like it, but that's a really smooth rail. That'll be a great rail for X. Put that up there. So let's see. That rail, it's dry, but it's smooth. So let's see here. Okay. I apologize. This probably isn't gonna. You're not gonna be able to see much when I'm over here, but I do not have the world's greatest camera setup yet. I need to figure out what to do for the. I need to figure out what to do for the V2.4 build I'm doing soon. I'll probably need to figure out something like Uber's setup where he has a camera above his work area. But that is the next on the list after this. So I'll be doing a good amount of V2 stuff here for the next bit. Some cool stuff I found out today. I talked to a member of our community who is I don't exactly know what his PhD is in, but he's smart. And I asked him if he knew some more about spring mass damper systems, because I figured if he did know, then he would probably know more than I did. I started asking him some more about belt tension and resonances, and if he thought how I was trying to model the resonant frequencies made sense, since I'm trying to essentially make a mathematical model of how the system is resonating. And he seemed to think I was on the right path, but during my discussion with him, I was able to find a document. I forget which university it was, but essentially someone wrote a short research paper on Gates belts, and specifically their essentially their stress strain characteristics, and discussing, like, looking at the length and stress strain curves, and essentially what they found was very similar to what I had imagined, which is essentially the stress strain curve is going to be the same no matter what your belt length is, which makes sense. It's the same fundamental material properties, hopefully throughout the belt. But as the belt gets longer, since strain is essentially your change in length divided by the initial length, or essentially, then as your length gets longer, your deflection is essentially going to change. So if you're looking at force versus deflection, as the belt gets longer, your for the same force, your deflection is greater. Which is, if you follow that train of thought for a while, you will get to the point where you realize that the larger your printer is, under the same forces, whether that's acceleration or deceleration or vibration or tension or anything like that, your belts will deflect more. Which also means that they're less stiff because they're longer. Your stiffness per unit length is the same, but which is essentially strain, stress strain, Young's modulus, but your K value, if you're trying to estimate springs as your belts as a spring, your K value is not that, essentially. It changes with length. And if your belts are less stiff, or your springs are less stiff, then it's going to deflect more, and you're going to get more resonances, and life is just going to be crappier. Which is why we generally advise, maintaining. This is actually the biggest one we advise, which is the 350. But I'm still going to go down this rabbit hole because I really want to get math behind that, because ultimately it's one thing to tell someone, yeah, don't do that, it's not a good idea, and say it's generally difficult to do and you're going to have a bad time, versus saying, here's the math on why this happened, and maybe even, okay, you're going to have to scale maybe acceleration by X with every doubling of printer size, your acceleration is going to have to drop by a quarter, or reduced by 75% or something like that. I don't know. It'll be interesting. I think there's probably some simpler assumptions that can be made in general. Just kind of like trying to simplify it further, but I've gone too far down the rabbit hole right now, and I need to know as much as I can, and if it ends up being, if the answer ends up being experimentally measure it, because trying to model it as a spring mass damper system is next to impossible, then that may be the answer. But at least I'll know that's the answer. The one interesting thing is that if you assume a spring, or if you assume the belt is essentially a spring, and you're only looking at the deflection, and you're assuming that the belt essentially is going to be a straight belt, and it's going to expand and contract along the length, then that's one thing. But if you realize that the belt can vibrate, then maybe something else happens. It's going to change its characteristics and how it behaves. And does that make I don't know what that does to the resonance frequency or to the deflection, but it's interesting to think about, and I like thinking about things, so. Oh, what was that? Ah. I guess I did take that off. Nope, that was almost through the other way. We will also be able to tell if the belts are equal lengths, which would be nice. The other thing you'll note is that you can't see it here, but as this motor is rotating, it is actually powering the display, because as a stepper motor rotates, essentially if it's rotating without being powered, it's essentially a generator. And that is also why you have to be careful. You don't necessarily want to, like, if you all of a sudden, try to see how fast you could spin the stepper motor and how bright you can make the display. It's very possible you could actually potentially kill something because your generated voltage may exceed the voltage rating of your microcontroller or your display or something like that, and you won't want to do that. And if you're also interested in stepper motor theory, which I will not say I am an expert on, but I do find it entertaining. Essentially, that same generation of voltage is essentially the same reason why stepper motors are they perform much better at higher input voltages. And the stepper motor itself doesn't really see that voltage, but if you think about it, if your stepper motor is rotating at a certain speed, it's generating a certain voltage, back voltage essentially. And if that back voltage is the same as the voltage that the stepper motor is being driven at, essentially, in kind of a simplified, not completely accurate term, but essentially, if the stepper motor is rotating fast enough that it's driving, it's generating 12 volts, and the stepper motor is being powered or driven by 12 volts, then essentially there's no extra power or voltage, no extra potential to rotate the stepper motor. So essentially at that point your torque value is 0. And so when we're talking about stepper motors, we like to refer to inductance fairly regularly, because the higher the inductance, the more the back EMF or back voltage generation is, essentially. And I'm probably saying all this correctly, but there's a possibility I'm not, and if I'm not, feel free to correct me. But Essentially, the higher the inductance, the higher the back EMF, and the higher the back EMF, the less torque the motor has at that speed. So if you buy a motor with high inductance, or even medium inductance, and then you compare it to a motor with low inductance, they may have the exact same torque at essentially 0 speed, but their torque at high speed is going to be completely different. So that is essentially what happened with the LDO 1004 motor. The inductance was too high, and so even though the torque value at essentially no speed was the same, so the peak torque, the torque at speed was substantially lower than other printers, or than other motors we've tested. And so that of course becomes an issue because your printer skips steps or has less torque available for if maybe your gantry's binding slightly or something like that. So that's not ideal at all, which is why we're not recommending those motors anymore. So generally when I'm looking for stepper motors, I'll try to find one that has the lowest inductance. So generally, I believe it's millihenry. That's the inductance value, or inductance measurement value typically used for stepper motors, and around 3 millihenry or so, or 3 to 5 is generally a good value. I think the spec motors that we have, these 17HS19 2004 S1, these have low inductance and high torque. And their torque is so high that even at 12 volts, and their inductance is so low that even at 12 volts they have a good amount of torque, and you can hit the speeds we need to. It's still kind of marginal at 12 volts, but if you go to a 0.9 motor, make sure you're on 24 volts before you do that, because you really don't have as much overhead at those voltages. So in general, a 0.9 degree stepper motor is going to have lower torque. So if you're at 12 volts, it's just going to not be enough. But I know it's a pain to buy a new power supply, and it's a pain to buy new fans and things like that. But if you're already upgrading, in this case, he had to buy new fans anyway, because he's going from the old V2.2 quick change tool head, which uses the 4010 centrifugal blowers and the 4020 axial, to essentially the new design that uses a 4010 axial and a 4020 centrifugal. Yeah, he had to buy new fans anyway, so he went ahead and bought a 24 volt power supply, 24 volt fans, and then the last thing is a 24 volt hot end. And I believe he bought one of those. If not, we will go ahead and I think I have a spare one lying around here. But and speaking from personal experience, because sometimes I'm lazy, and I think one time I wired up a 12 volt heater cartridge, thinking that's interesting. You got a push notification, because I thought this one was unlisted, but oh well. Anyway, it is what it is. But the what am I saying? If you're gonna upgrade from 12 to 24 volts, please buy a new heater cartridge for your heater. It may be tempting to say, oh, it'll still work. It's I can just limit the max power. Don't do that. Essentially power is voltage squared over resistance. So the fact that you double the voltage going from 12 to 24 volts means that with the same heater cartridge, which is essentially a resistor, the power increases by a factor of 4. And if you had a 40 watt heater cartridge before, now it will be at 160 watts, which even if you're using a bed MOSFET, the heater bed MOSFET instead of the hot end MOSFET, that's still kind of on the verge of being questionable, especially depending on your printer. And also the fact is, if you use a 160 watt heater, essentially, it's going to heat up almost instantaneously. And if you ever have an issue like your MOSFET fails because you're running too high current through it, which is essentially exactly what you're doing, then you're going to have a 160 watt little heater that is going to melt everything around it and catch fire. And then your printer is going to be essentially one of those ANET fire posts on the 3D printing forum, where you're going to say, I burned my house down because I decided I wanted to use a 12 volt heater cartridge even though I upgraded to 24 volts. So yeah, we don't want to have a Voron as a cause of someone's house burning down or anything like that. It's just not, it's not good. We want people to have fun. We want this hobby to be safe. Yeah. And it really isn't significant cost. A heater cartridge is, to a certain extent, a heater cartridge. They're very basic devices. You know, they've been, I mean, it's not anything high tech that's, you know, I don't know. It's just a resistor and some, I forget what the powder is called, and with a casing around it, but there's not much to it. So you can buy one off of Amazon, and you should be fine. There are so many parts in the V2.2 A/B drives. It's kind of mind-boggling. The accent colors do look really cool. I will tell you that. V2.4 definitely does have less accents, but from a printing standpoint and assembly standpoint, it's nice. And also from a screw count standpoint, there's just a lot less stuff, which is great. And there's no stepper dampers in V2.4 either, so. And there's also no closed loop belts, so I'm glad I don't have to worry about those as far as calculating tensions and resonances either. So. And so these bearings here, they're actually pretty good. This stack is a little bit, it is interesting. You can almost see like some belt residue or something like that on there. I'm not exactly sure what that is, but it's a little, they rotate decently well, but it's a little resistant. And that's really, those points, essentially wherever you have a pulley or a bearing that is supposed to be rotating, being sure to get those places rotating freely is really probably the biggest thing you can do to make sure that your printer is going to work well. Because ultimately, if your printer has so much resistance that it takes 10 times the amount of torque to move the tool head than it's supposed to, then nobody's going to have a good time. No matter what stepper motors you have, they're not going to work, and yeah, that's going to be sad. So really, attention to detail when you're assembling the gantry is key. And again, there's a balance between cranking stuff down too tight and not tight enough. But especially with this bolt in V2.4, I won't get to it tonight, but this bolt is nice on V2.4 because you can use it kind of as a preload, where you can kind of adjust it so these bearings don't really have play. They can't slop around essentially, but at the same time, you know, they're able to spin freely. Bulk the cartridge with other stuff. 100% agree there. I'm just speaking from experience. Sometimes I'm lazy and I want to get stuff as soon as possible, which is not always a good thing, but certain things you don't want to wait a few months for, especially after you have your printer. Like if there's something you need, like for instance, if you upgraded to 0.9 degree motors and you still had 12 volts and so your printer wasn't printing, then you would want to figure out how to get stuff working ASAP, and you'd want to use 24 volt. But that's a corner case. I'm happy we have 24 volt as spec now, because really it's how things are supposed to be. So if you have just come to the Voron community, you'll remember in the past, there's two cases here. This one, for instance, is a press fit just 625 bearing, and getting the essentially extrusion right so that your bearing essentially presses in easily by hand but doesn't have slop is really tricky. So that's why the Voron cube actually still has a hole diameter on the bottom for or maybe the bottom or top. One of them is for the 625 bearing, which is non-flanged, and the other is for this F695 bearing, which I think the V2.4 does not use any embedded 625 bearings like this, and for the Z drives for V2.4, they do have a press fit for the 625 bearings, but they're in a clamshell that comes together, so you don't have to get it quite as good as this. But anytime I see a part like Magdalene's part here, it just snaps in like with a small push, and it goes in so nicely. That's the sign of a really well-tuned printer, and it's hard. The tricky part though is getting the balance between getting your bearing to fit well, and under extruding or over extruding is really tricky, which is one of the reasons why we wanted to get away from these, because potentially you could be, depending on your printer build and how accurate your holes are, maybe you would have to really under extrude in order to get the bearings in, but then the part's not going to be as strong because your part's not really the layers aren't bonding together well because it's under extruded. So I think that's one of the biggest improvements for V2.4 is just getting rid of all these, even though they're really satisfying to put in. It's almost like you should keep this around like a fidget spinner or something like that. And also these Astros and dampers, they're not bad, but it's another place where, especially on the V2.4 or V2.2 Z drives, since you had, let's see here, if I can put this back together temporarily. In this you had essentially a screw where you would tighten this and it would pull the stepper motor away from this, so you'd tension your pulley that way. It's really easy when you have a threaded thing like that to and especially when your loop's this small, like a small amount of adjustment on that is a huge amount of strain adjustment on this loop. And so it's really easy to hulk those over, and that's why sometimes you'd see stepper motors like leaning to the side, and that's just not, that is generally a sign you've tensioned it too much. You really don't need to go that tight on things, but it's easy to do. Nobody really understands that belt tension or how tight things are supposed to be, so it's really tricky to know, and until you've done it a few times, honestly, I don't even know right now. I know what tends to work well, but I don't know like what should be done, and so it's tricky, and I really don't want to round this one out. Come on. I'm scared. I'll leave that one in there for now. Is that what I think it is? Does anyone notice? This is also the other most frequent thing. If someone puts the wrong pulley on a motor, or for the Z drives or something like that, essentially this is a 16 tooth and this is a 20 tooth. So essentially your step distance for both of them will be different. If you have that on one of the Z drives, then essentially one Z is going to go up and down a different amount than the rest, and it's going to be hard. The nice thing though is, as long as they're all the same, you can kind of compensate for this fairly easily, it's happened to almost everyone, especially when your stepper motor kits are, or like when they're all the same color. It's easy to do. So, but yeah, if for some reason you put 20 tooth pulleys everywhere on your Z drive, they're supposed to be 16 tooth on the. So this is obviously not the Z drive, but down here, and that's actually a good point. These two front are 20 tooth on the motor, and the back two are 20 tooth as well. So he has 20 tooth everywhere. So if you think about a gear ratio, 20 tooth and 80 tooth is a 4-to-1 gear ratio, which honestly will work fine. But you'll have to adjust your step distance because the spec uses a 16 tooth to 80 tooth, which is a 5-to-1 gear ratio, which will allow a little bit more torque. And the really important thing there is, especially in the back two, at a 4-to-1 gear ratio, the back of your gantry may fall a little bit more, which again, as long as you quad gantry level, and every time you turn off your stepper motors, which you really need to be doing anyway, it's not a huge deal. But now that I have noticed that, and I do see a few of these 16 teeth pulleys lying around, that is probably one of the things I will fix in an upcoming stream. But for now, until we get the rest of the system running, I'm not going to go running off trying to find things to fix that don't expressly need to be fixed, because ultimately I want to get this printer back to him functional and running as soon as possible, because he's been patient with me. I've been busy the last, I honestly don't know, it's been months, probably May time frame, right about the time I knew I was buying a house and moving soon. Was about the time he reached out to me and let me know that he was in my city and I just wanted to meet up and get some tips on his printer. and I offered to help him out because it's really cool to have another Voron owner in your city. So I met him for the first time a few days ago when he dropped this off, and we're getting it fixed up. So all of his friends have Prusa printers, which are great, but he wanted to build a Voron, and it'll be great to finally get this one operational. So we have our Z belts. Again, these are 6mm belts, which is for a 350 on a new build. You definitely want to go 9mm. I'd probably say almost any build side you go 9mm for your Z. But many people have survived for lengths of time with 6mm belts for Z, and they've been fine. He's going to go ahead and buy some 9mm though, so maybe in a month or so he can swap those out, or maybe longer than that. We'll see how COVID shipping goes. But let's see, it's just a few more parts here. The other thing you'll notice here is the threaded parts. Those are no longer around, but there's threaded tensioners on the Z drives for V2.2, and there's also this threaded adjustment piece for the stack, essentially. It's kind of like a preload on this, which is kind of cool. It's nice to be able to thread in parts like that just kind of work. I think this was actually an earlier version of the parts that the threads were maybe a little bit too fine, so they were more tricky to print. But again, Magdalene has a fantastic profile here, so he nailed it even with the more the finer threads that are more difficult. So, but it is cool. Again, you can always find any of these parts on the Voron 2.2. So there's a Voron 2 repo. If you select the drop down on the branches, and instead of selecting Voron 2.4, you select 2.2. You can grab these parts if you want to test print the threads, or even if you want to get some design suggestions on clearances for threads like this for your own parts. You can use those. So they work, they work well. So let's see here. And you'll notice as well that he is using, this is a metal shielded F695 bearing, which is called a ZZ. It has a ZZ at the end for metal, so F695ZZ. Technically the spec on this is F695RS or 2RS, which is a rubber seal. Like this is an RS bearing, a rubber seal bearing. However, these bearings are a lot cheaper than the RS bearings, the rubber seal. And honestly, I've been running these ever since I built my first Voron printer. I've probably been circulating the same bearings over and over again. So occasionally you'll get a bearing that leaks out. You'll get that no matter what. But honestly, in my opinion, they're fine. If you want to save a few dollars, you can do that. However, that is much less of a important factor now that we've reduced the amount of those that we're using. So if you think about it, before the front idlers had 4, these XY joints had 4, the AV drives had the same 6. So there was a lot more bearings used, because essentially these, you can't see it down here, I don't think. But essentially anytime there was, instead of using a tooth idler in this case, there was a shaft with a bearing on either side, which is cool because theoretically one of these bearings is a lot bigger. The ball bearings is a lot bigger and can maintain, survive a lot larger load than one of those tooth idlers. but it's just a pain in order to get this assembly to work properly, you know, and to not have any issues. So, yep, it's a good riddance in my opinion. If you really have issues with tooth idlers, there's only 2 of them in the V2.4, and it's really easy to swap those out. So let's see here. So we have essentially everything removed except these. It's allowed and give it a try. But it's honestly, they're pretty smooth. So if I can get away with it, I'm going to leave these 4 Z rails here, and that would require essentially this rail here getting some attention, so it doesn't have issues. But let's see here, which side? I think it's this side that was kind of loose. Okay, so again, be careful. Don't want anything to happen there. What I'm going to do is I'm going to take out this, see if you can see it here. I'm going to take out this one. And then I'm going to just, oops, maybe I'm not going to. I was expecting that to be a ball bearing instead of a. But what I'm going to do is, see, I stuck a longer M3 screw there into the T-nut and tightened it down against the extrusion so it's not going anywhere. So that's a natural stop there as I'm taking everything else off so it doesn't fall off. And this is kind of creative how the Z end or the end stops are kind of integrated into this bottom piece. Looks kind of sleek, but you do notice here, essentially with how long this lever is here, it is actually slightly hitting this piece of plastic, and hopefully it won't be an issue, but it could catch and maybe, you know, be an issue down the road. But I don't think V2.4 has that same issue, so we should be good there. Okay. Hopefully we can just slide this off. Or maybe it's tight enough that I can't actually slide it off until I loosen tension on that. Oh, there we go. That worked. So again, down here, I'm going to do the same thing I did before. I'm going to grab any old random longer M3 screw. This time I'll keep it flat so that T-nut doesn't slide around. Then I'm going to go ahead and tighten this back in. So there's that. Then we can go ahead and take off this carriage here as well. Let's see here. This is mainly all M3 socket head. I should have brought up my. It is really nice to have a good set of hex wrenches that have a ball end on one end, because sometimes there's just things that you can reach with that you can't reach with something like this that is a little bulkier. Go ahead and take this probe out. Just slides down through there, so that's really convenient. And I will grab my smaller hex for this. There's that. Put this over here. Take out those. And take off these last few pieces here. Again, I'm a little, it's, you know, we won't get the 2.2 to 2.4 resonance differences, but I think there's enough other data in the community. I think it was Stefan had a 2.2. I forget if it was with the Afterburner toolhead or not, but if you have a 2.2 still and you haven't updated it to the Afterburner, be sure to reach out to me because I'd love to get some accelerometer data from a 2.2. But again, you'll notice if you go back from a 2.2 to a 2.4 how much easier it is to push the toolhead around with the motors powered off and that sort of thing. And that's a really big deal, you know, because if you're having to fight every pulley, because it's just there's so many sources of potential resistance, then it's not fun to build because you're having to really use a lot of finesse to tweak stuff, and it's just a pain. Yeah, there we go. And if you have never used, if you've never deflanged a 20-tooth pulley, then you can be thankful for it to be 2.4. V2.1 did not need the deflanged pulley because the instead of mounting the X carriage to the front, it mounted the X carriage to the bottom. And the belts were here, so you had a lot more. Freedom to offset the belts slightly. So then, if you're offsetting the belts, then you have more clearances around the pulley, so they don't need to get stacked up quite on top of each other like that. And again, these XY joints are really pretty, but they're also a lot of parts. There's quite a few parts here. There's a lot of hardware. Where the 2.4 XY joints are just 2 parts, which is nice. So, but there is just about all of it. If there's any questions, I realize there's only 4 of you there. So, if any of you have any questions, feel free to let me know. Otherwise, I will be wrapping up here in short order. And right on time, too. Right before 11 o'clock. So, while this wasn't exactly the what I was planning on doing tonight to this printer, it is good. So, So there's our pile of, and you can't see it, but move this down. So there's our pile of parts from the V2.4 Gantry. And let me grab the parts. Here are the new parts that I printed for this printer. It pretty much has most of the things printed. I'll have to put it all in the heat certs and assemble everything. It's going to take some time, but at least the gantry part, everything other than the gantry, I should be able to do in a single stream, maybe tomorrow night, who knows. But and with that, thank you all for watching.